So, we've kind of went through this already. So this is kind of review. Again, remember, what I do up here could help you in your trend that you're trying to explain. It could help you understand why certain elements want to gain electrons and why they don't, or vice versa, why they are willing to give up electrons and why maybe they're not willing to give up electrons, okay? So, as I go through this, this is sodium. This is the model of sodium that we could have. And in this model, this is what it would look like. And inside here, I'm going to put 11 protons. 281. Now, they're showing a picture of sodium. What happens to this atom for sodium when it becomes stable? What's it going to do? So what's this sodium model of atom? What's it going to look like on the right side? Bigger or smaller? Smaller. What makes it smaller?
It loses that level.
So there's that one electron. It loses that one electron. Then we've got a model over here. The 11 protons, 2 in there, and then it shrinks down a little bit. Okay? And so this would be, oh, I messed up already, didn't I? Okay? So that's what it would look like. It's got the 11 protons in there. It's got 2 and 8. Okay? So that's what it's going to look like. What will this one look like? Second one. Configuration. What will it look like? Over here. Right?
Yeah.
And we know that neon's configuration, I'll write it down below, is 1s2, 2s2, 2p6. That's what neon is. And it basically obeys the octet rule. I'll say that from time to time, the octet rule, meaning that there's 8 there, and it's stable in that position. What will this Na look like on this right side? We've got an electron there, which is this S1. What will it look like over here? We want to put a +1. Now we can look up here and we know why it's a +1. There's 8, 9, 10 electrons, 11 protons. So we can see throughout what's taking place in electron configuration. We can look at what takes place in this model where we're showing the layers. It becomes a +1. Any questions with that? Okay? All right. Now, below this, this is going to have all those levels full up. So, you don't have to do this one. I'm just going to do magnesium because it's there also. So here's magnesium. Magnesium, I think, is 12 protons in the middle. And it's got 2, 8, and 2. And this one would be 2s2, and then we've got the 2 dots. So what's going to happen to magnesium? It wants to get rid of those 2, right? It wants to have 8. Easiest way to do that is to get rid of those 2. So it's just like sodium, but it gets rid of 2 instead of 1. And it's 12 protons in the middle. This one's also going to take on neon's configuration. And what's magnesium going to look like? Mg +2. 12 versus 10. Got a +2. Okay? So then, if you turn over the page, there's a chlorine. Page 168. So, both of these have got to configurations. There's a noble gas. Now we have chlorine. Chlorine is got 17 in the middle protons. It's got 2, 8, and 7. Electron configuration for chlorine is 3s2, 3p5. And when we do the Lewis symbol, that's what we have. So, getting back, I'm going to come back to this page, but getting back to students that have things called electron affinity and ionization energy, okay? Ionization energy. Sodium's at the beginning of the third period. Its ionization energy is lower. Okay, here it is. This is what it has to begin with. Its ionization energy is lower. This is a model of it. Chlorine has a higher ionization energy. And this is the electron configuration for it. Okay, it's in the same period. Okay, it also has a higher electron affinity. Chlorine has a higher electron affinity, wanting an electron. Sodium has a lower electron affinity. It doesn't really require or needs to have an extra electron. So when you're thinking on your explanation of why ionization energy and electron affinity, then you might be looking at making some of these drawings and doing some comparisons. Okay? So chlorine, what will it do versus the previous two? There is chlorine. What's it do? Yeah.
Fill another level.
Yep.
Like
We're going to have
finish
to.
the level.
We've got to finish that level. And what do we need to? And really, we're not finishing the level because that third level can have 18.
Well,
But we are kind of finishing that level because the most you can have in the outer level at any time is 8, right? So in a way, we are finishing that level off. So we gain 1, right? So it has 17, and then it has the layers, and that layer is a little bit bigger because we've added an extra electron out here, and without adding a proton in the middle. And it becomes where we have is that right? Okay, that's 18. 18 electrons and 17 protons. Okay. Now this over here will gain that electron and become neon 3s2 3p6. And now it's like argon. You could write argon, but this kind of shows you that it's not losing to get there, but it's gaining that 1. So it gains that 1, and so this chlorine is over here. And what charge is it? -1. It's got 18 versus 17. So it's a -1. Okay, so let me show you a little bit about the periodic table and kind of how we can look at trends on the periodic table, what happens on certain groups, and you guys can tell me if it makes sense or not. So we have metals. Now metals on the left side, we already know where the metals are at. We know where the non-metals are at, and metals tend to lose electrons to get an outer layer of 8. Non-metals tend to gain because of their position and how many electrons they have in those layers. Okay, so that's a really good, real quick view of 3 different ways to look at what's going on. When we look at the periodic table, you guys don't have to draw this out. So, What charge will this group 1 be? What do you think? Because it has 1 dot, right? The alkaline earth metals, what charge will they be? That makes sense? Loses those 2. Becomes like this group. What about this group? What will they tend to lose or gain? They don't have charges. Okay? That's why when we get to the noble gas, some of you guys have zeros down there for like electron affinity. It's 0. Those people that are doing that, this is 0, that whole group. Okay? The one next to it is drastically different when it talks about electron affinity. It's the highest ones. These are the highest next to the ones that have 0. So what charge is the fluorine group? Now, most of this group is this charge, but not all of it, because what happens is we get into this area where we go from non-metals to metals down in the lower section. So we cannot say that everything in this group will be a -2. But we can say oxygen probably and sulfur and this next one, they would be. Okay? And then I know I'm out of sequence when it comes to the link because I'm going to run out of room. But I'm not going to go any further than this. What's this group going to be? -3. Okay? So it'd be kind of like having this nitrogen here. Nitrogen has 5 of the dots. So you guys can see why it's -3, right? Because you're going to get locations where now it fills and it's a -3. Okay, so why are we doing all this? Why are we looking at these charges and that? Sometimes we can even look at this one and it'll be a +3. And then this one's a +3 here at the very end. I know I'm off on my count, okay? And probably shouldn't put that there, but we know the next level, aluminum boron, is going to be +3 when we get there. Okay, and we can go over that too in the future because you don't need all of that right now. So here's the deal. We're going to take and look at these when they're floating around one another. Okay, when they're in the same vicinity. When we put certain elements that are in their raw form together, what's going to happen? So what's going to happen if I take a chlorine and a potassium and have them want to become stable? What does potassium have to do to become stable? Lose an electron, +1. Chlorine, going to add 1. Where does that 1 come from? Potassium. See, it's not going to get its electron unless there's something that's willing to give it up. Potassium's willing to give it up. So these two, when they're +1 and -1, what are they going to do? They're going to get together. They're going to attract one another. So when they attract one another, the ratio, the charges have to balance. So, is 1 of each, when we add them together, would we get 0? Right? If I would take this one and add it to this +1, I get 0, right? And that's what I want. Every combination has to be 0. So this formula would be KCl. That's what it would be. If we have a bunch of them floating around, they'll always combine in a same ratio, 1:1. Okay? So, some of you have electronegativity, right? Okay? This is for people that have electronegativity. If these two get together, and I'm not going to do everything to scale, but if these two get together, which one is going to have a greater share of that electron, chlorine or potassium? Because they're going to basically be together, and there's going to be some electrons in here, okay? And if they look like they're sharing, which one do you think is going to have a bigger share? Which one?
Chlorine.
Chlorine. Okay? Potassium's not going to have as much of a share. So hopefully you can understand by looking at their electron configurations why chlorine would have a bigger share versus the potassium, which I don't have drawn out. Okay? Let me give you a couple more scenarios and then I'm going to let you go. We'll give you plenty of time. You guys have about 20 minutes. What if we put magnesium with nitrogen? First of all, what do we want to do? We want to figure out how many's lost and gained total, right? So how many does magnesium lose? 2. What charge? Positive 2. Nitrogen? Gain 3. What charge? Negative 3. If I put this one down here and a minus 3 down there, the net charge doesn't work. Okay? And so all I have to work with is a 2 and a 3. So since it's a minus 1, I bring another one in. Now when I add them up, what's the charge going to be? Positive 1, not good. Alright, so I bring in another negative. Now what's the charge? Positive 2. Now, or negative 2, right? So what am I have to do? Now the charge is 0. I'm good there. Now, you're not going to have to do that every single time. Okay, let me bring in the math in. Okay, what would this formula be then? Mg 3 N 2. Okay, so instead of doing this, let me bring in this thing you do in math. When you add 1/2 plus 1/3, what do you need to do? You got to have a common denominator, right? What's it going to be? 6. Okay, here, I've got a plus 2 and a minus 3. I have to get both charges to 6. So how many plus 2s am I going to need to get 6? 3. How many negative 3s am I going to need to get? 2. And that's your formula. Instead of drawing them out each separately. It's nice to see separately how they equal out, but you have to get the point. If I give you a plus 2 and a minus 3, you have to know that you have 3 magnesiums for every 2. That's the ratio it needs to be. And that's about as hard as it gets when it comes to comparing the ratios. Okay. All right, your assignment is up on the board here. If you can see it, I'll put it up here for those who are having to watch the video. It's page 171, and it's problems 2, 6, 8, and 10. And then page 174, 16, 18, and 20. And so hopefully me drawing out some structures can solidify what you guys are doing on your boards and can help you explain why the trend is working the way it is and giving examples by drawing models or the configurations or any of that. Okay? This is something I'll come around and check if you have it done, just like we've done on past assignments. So, yeah. And I think they pretty much got done with it in the previous class period, third period. They pretty much... We probably won't look at this until Monday. Because tomorrow I'm going to give you all period to...
Will we even be in that?
Yeah.
It's only third period.
It's half of
You might miss, if you're in band or choir, you might miss a little bit of this period. So that's why what we're going to do tomorrow is just, when you come in, we'll just, whoever's here in your group will get the board and you guys will... You guys tomorrow can start putting your board together and leaving it on. Leaving your writings all on there. Because I'm going to have enough. I'm going to go get some more boards and cut them. But you're going to have enough boards that where every class, the group of 3, will have their own board, and then we'll just put it away in the back. And then you'll add to it or take away from it, and you won't have to do any more erasing, because I know that becomes pain. So you can probably start putting your sections together on your board starting tomorrow. That process. Okay? So we probably won't look at this assignment till Monday.